Hi class, in this video I'm going to be talking about how to identify fractions that have repeating decimals. So the rules for identifying them is this. Any fraction in its simplest form with a denominator, so the number on the bottom, that contains prime factors aside from the prime factors of 2 and 5 will be a repeating decimal. So first things first, what are factors again? Factors are numbers that can multiply together to create another number. Prime numbers are numbers that only have two factors, one in itself. So 2, 3, 5, 7, 11, etc. These are examples of prime numbers. And prime factors are factors that contain these prime numbers in them. So right now I can already tell you 1/3 is going to be repeating. Same with 1/6, 1/7, and 1/9, and I'll show you why. So let's say for 1/3. For 1/3, I want to consider one of my factors of 3 for my denominator. So factors of 3 are going to be 1 times 3. Now 1 isn't a prime number, but 3 is a prime number. Hence, that's a prime factor that isn't 2 or 5. So 1/3 is going to be a repeating decimal because of that. Okay, let's do another example. Let's say we have 1/6. So for 1/6, let's find my factors of 6. So factors of 6 are going to be 1 times 6 and 2 times 3. Now, 6 is not a prime number, so it doesn't matter. Neither is 1. 2 and 3 are prime numbers. However, the one that I care about is 3 because 3 is a prime number or a prime factor that isn't 2 or 5. So because I have a prime factor that isn't 2 or 5, that means 1/6 is going to be repeating. So this is going to be 0.16 repeating. Okay, let's go over a couple more examples. So now let's say I have 1/7. My factors of 7 are going to be 1 times 7. And 1 isn't a prime number, but 7 is. So 7 is a prime factor that isn't 2 or 5. So because of that, that means 1/7 is going to be repeating. And it's going to be 0.142857 repeating. All these digits just keep repeating now. Okay, now for 1/9, my factors of 9 are going to be 1 times 9 and 3 times 3. Now, since 1 and 9 are not prime numbers, 3 and 3 are my prime numbers. And because 3 is a prime factor now, and it's not 2 or 5, that means 1/9 must be a repeating number. So in this case, it would be 0.1 repeating. Okay, now let's use long division to kind of verify if this is true or not. So let's apply long division for 1/3, right? So I have 1/3, which means I'm going to have 1 with a 3 like this dividing by it, okay? So now, how many times can 3 go into 1? 0 times. So now I subtract that, I get a remainder of 1. Now this is the part where we add a decimal. So notice that 1 is the same as 1.0, right? So now I add a decimal up here because I added a decimal here. And now carry down this 0 to make this 10. How many times can 3 go into 10? 3 times, right? Because 3 times 3 is 9. So now 10 minus 9 is 1. I once again add another 0. I bring it down. This is 10 again. How many times can 3 go into 10? 3 times. So I'm going to get 9 here, remainder 1 again. I add another 0. I bring it down. It now becomes 10 again. How many times can 3 go into 10? 3 times. 3 times 3 is 9. I subtract that, I get a remainder of 1 again. Can you see how this pattern will continue on forever? Hence why 1/3 is 0.3 repeating.